Hello guys, welcome to Ramta Solutions. Today we are looking at geometric series. Remember, the general formula for a geometric sequence is Tn equals AR to the n minus 1. So for a series, which is a sum of terms of a sequence, we will say, maybe let me not write it like this. Let me just say T1 plus T2 plus T3 plus T4 and so forth, right? Now, let's consider maybe sequences that end up to, okay, Tn minus 2, Tn minus 1, and Tn. Let me do it in that way. Now, the first term, according to a geometric sequence, would be T1 would be AR to the 1 minus 1, which is AR0, which is A. And T2 would be AR to the 2 minus 1, which is A to the R, AR to the 1. Then T3 would be AR to the 3 minus 1, which is AR squared. In the same vein, maybe T4 would be AR to the 4 minus 1, which we can say it is AR cubed. Now, if we want to find your Tn of minus 2 or T of n minus 2, we would say this is AR. Where there's n, remember, where there's n, I put n minus 2, so it would be n minus 3, right? It would be n minus 3, right? Okay. Continuing, Tn minus 1, I will say it'll be n minus 2, and then Tn will simply be AR to the n minus 1. All right, it will simply be AR to the n minus 1, right? So now I think I want to go to the next page because I want them to be in one page. So we say Sn equals T1 plus T2 plus, let's say, T3. I think that can work. Yeah, plus Tn minus 2 plus Tn minus 1 plus Tn. In the previous page, I had shown you that we can say Sn equals, what is T1? T1 we said it was A, T2 we said it was AR, T3 it was AR squared, and this Tn minus 2, it was AR to the n minus 3, while this n minus 1 was AR to the n minus 2, and finally Tn was AR to the n minus 1. Let's call this one here equation 1. So now let's multiply equation 1 with R. So meaning we have R Sn equals, if I multiply everything by R, it'll be AR plus AR, this guy, when I multiplied by R, it'll be AR squared. This one will be AR cubed plus this guy here will be AR times, okay, AR to the n minus 3 times R will be n minus 2. This one here will be AR to the n minus 1, while this one will simply be AR to the n. And I'm gonna call this equation 2. Remember, I'm multiplying everything here. I'm multiplying everything here by R. So I'm gonna summarize this in two ways. Okay, rather I will complete it in two ways. We will have option A and we will have option B. So for option A, we will say, let's say equation 1 minus equation 2, right? So if it's equation 1 minus equation 2, we have Sn minus Rsn, Sn minus Rsn. And what does it mean? This part minus this part. So this minus this, as you can see, this will minus this, it will be 0, 0, 0, 0, 0, 0, 0. So when I look at it, it looks like I will be left with A minus, oh, this and this are out, so it will be A minus AR to the N. Okay, I repeat, this minus this, Sn minus Rsn. A, and here we don't have A, so it means A is okay alone. AR can minus this AR squared can minus this AR squared, and obviously after this AR squared there's another AR squared here, so it'll minus this. Similarly, they minus like that, hence I'm left with A minus AR to the N. Now there's a common factor here, which is Sn, and then we are left with 1 minus R. Here there's also a common factor, which is A, and we are left with 1 minus R to the N. Now therefore our general term here, rather sum of terms here, is A times 1 minus R to the N all over 1 minus R. Right? Now for option B, I will say equation 2 minus equation 1. Equation 2 is Rsn minus Sn. So I said equation 2 minus equation 1. So again, it's this line minus that line. So these will cancel, these will cancel, these will cancel, just like that. So this one, it'll be AR to the N minus A. Right? Common factor again, we have Sn, R minus 1. Here common factor is A, R to the N minus 1. Therefore, Sn equals A into R to the N minus 1 all over R to the, all over R minus 1. So there are two formulas to calculate sum of terms of a geometric series. The usage of either of each of them or either of them depends on the value of your R. Okay? So when you say Sn equals A into 1 minus R to the N all over 1 minus R, here you must use this formula here when your R is less than 1. Okay, when your R is less than 1, you must use this formula. Doesn't matter what value it is, as long as it is less than 1, you must use this formula. Now you also have this one, A into R to the N minus 1 all over 1 R minus 1. You must use this one when R is greater than 1. Something that I want you guys to note is that I said when R is less than 1. So it doesn't matter what R value it is, as long as it is less than 1, you can use this formula. When it's greater than 1, you use this formula. Greater than 1 is any number from 1, 1 and so on. It's this one. Now any number from 0,9 below, you use this one. Okay, now this is how we derive our geometric series formula. Okay, so now we will then be able to know what is the sum of terms. It is easy now to calculate the sum of whatever number of terms that are given to you. Okay, again, Sn seems is still the number the sum of certain first numbers or certain terms of whatever series you're looking at, where n is the term number, a is the first term, r is the common ratio, just like that. So nothing changed here. We're still saying Sn is the sum of first n terms. Okay, now we're going to have an example. For our example, we will say calculate the sum of the first 12 terms. Okay, for number 1, we have 1 plus 3 plus 9 plus 27, and so on. Number 2, we have 9, 3 plus 1 plus 1 over 3 plus, and so on. Number 3, we have 120 plus 60 plus 30 plus 15, and so on. Right, and so on. So, without any waste of time, remember this question asks us to find S of 12. Right? Let's look at number 1. We have 1 plus 3 plus 9 plus 27 plus, and so forth. Now, as we can see here, our first term is 1. What is our common ratio? T2 over T1 is 3 over 1. This tells us that our common ratio is 3. Even if you use T2 over T3 or T4 over T3, you will still get 3. Alright? So, we're going to use this formula here. Sn equals A into R to the n minus 1 all over R minus 1. Remember what I had said. When R is greater than 1, you use this one. Right, so let's see. We're looking for sum of the first 12 terms, which is 1 into 3 to the 12 minus 1 all over 3 minus 1. Let me take my calculator. It'll return, oh boy, 3 to the minus 1 all over 2. So here our answer is, sum of the first 12 terms is 265,720. That's the sum of the first 12 terms of this series. Okay, great stuff. Now, number 2, we had 9 plus 3 plus 1 plus 1 over 3, and so on. Again, our A is 9. Our R, I will use T2 over T1 equals 3 over 9, which is equal to 1 over 3. Alright? Now, sum of terms that we're going to use, as you can see here, R is less than 1. So we're going to say Sn equals A into 1 minus R to the n all over 1 minus R, which is 9 into 1 minus 1 over 3 to the 12, by the way I should say S of 12, to the 12 all over 1 minus 1 over 3. Now we have 9 into 1 minus 1 over, oh boy. Do not forget to add this 1 over 3 in your bracket like I did. Okay, especially the one at the numerator. Over 1 minus 1 over 3. Our answer here is 13,50. Okay, our answer here is 13,50. comma 50, 13, comma 50. Okay, great stuff. Now let's try the third one. Number 3, we had 120 plus 60 plus 30 plus 15 and so on. Here our A is 120. Our R, I will use T2 over T1 is okay. R equals T2 over T1. T2 is 60. T1 is 120. I see this is a half. As you can see, R here is less than 1. So we are going to use this formula that says sum of terms equals A into 1 minus R to the n all over 1 minus R. What is our A? We said it was 120. What is our R? It was half to the power 12, or sum of 12, of course, to the power 12 all over 1 minus half. So let's see. 120 half. The answer that I'm getting now is, we have the sum of terms is 239,94. All right, guys. So this is how you calculate your sum of terms of a geometric series. Okay. All right, guys. See you next time. Bye.